Be talking to you about the Programming Merit Badge today, and we're going to be going over what some of the requirements are for getting a Programming Merit Badge. So my credentials are well, in addition to being your counselor for this particular merit badge, I've been in this industry for about 14 years. I started back when I graduated from NYU Polytechnic with a degree in computer science back in 2004. I've worked in various different aspects of the IT industry to where I am right now as an IT manager over at Bank of America, managing a team of software engineers. Today we're going to be looking at what it takes to be safe in a programming job. We're going to be taking a look at some of the history of programming, and we're actually going to get our hands dirty a little bit and write some code. So hopefully this will be insightful and will help you to get the proper skills under your belt for the Programming Merit Badge. So let's just talk a little bit about what the expectations are for today. We're going to be going through the requirements for the Cyberchip. We'll be going over the requirements for first aid and prevention, for history, and for writing subroutines in JavaScript. The expectations for this class are that you're going to fill out the Programming Merit Badge workbook, which you can get online. I'm also going to be sending that out in an email. The workbook will help to provide all of the information that you need to share in order to demonstrate to the counselor that you understand the materials. If there's not sufficient room in the workbook, you can add additional verbiage into a Google Doc, or you can write it in a notebook and scan that over and include it with the workbook itself. This will make sure that you're able to provide all of the information. There's not a lot of room on some of those sections, and I want to make sure that you're providing all of the information to demonstrate that you understand what we're going to be going over for these next few lessons. Lastly, the code that you're going to write does not need to be transcribed. Don't expect you to write all of the code into the workbook, but I do expect you to write the code so that when you're answering some of the questions, you understand the core concepts that underlie what we're talking about as we talk about programming and software engineering. The code, if you want to, there are definitely ways of sharing code. So if you wanted to send me a link to some of the code that you worked on, I'd be happy to take a look at it. I'd even be happy to provide you with some feedback, but it's definitely not a requirement of getting this merit badge. So with that out of the way, let's talk a little bit about the Cyberchip. The Cyberchip is something that's designed to make sure we keep you safe as the BSA while you're online. This is something that was created in conjunction with NetSmarts to give children, to give all scouts a understanding of what is cyberbullying, what is identity theft, and how to be safe when using cell phones, texting, blogging, gaming, or doing anything else that takes place online. Cyberbullying, obviously, is the act of attacking or verbally abusing people online that is considered no different than bullying people in real life. Bullying people online just because you're not doing it face-to-face doesn't change the fact that it's hurtful, and it's something that we should refrain from doing. And identity theft is really the keeping your personal information secure so that you're not exposing yourself or giving people online access to information that can compromise your personal information and allow people to impersonate you or use your personal information for their gain. The Cyberchip has a whole program that you'll go through to understand those things in much more detail. I believe Stuart's already gone over that as part of one of the virtual meetings, but if you haven't done that yourself, It is a requirement for this merit badge, and if you have not done it in the last year, it does need to be renewed annually. So please make sure that if you're participating in this particular merit badge, that you're making sure that that's all up to date. A link to the Cyberchip program is in the PowerPoint as well, so you can use that as well to retake the test if it's something that you need to retake or take it for the first time. So let's get into the meat of this. First aid and prevention. This is requirement 1B. There's a few different injuries that can be sustained from working at a desk job, working on a computer. I know a lot of times when we think about injuries, when we think about the first aid in Boy Scouts, we think about people being injured out on campsites, out on hiking trails, working in wood shops, working on things that could, potentially cost us our lives, and those are things that need to be taken very seriously. But that doesn't mean that taking safety seriously with working in a IT job or working at a desk job doesn't need to be taken seriously as well, because there's a lot of injuries that can be sustained that can cause lifelong pain and suffering. So just going to talk a little bit about some of the common what are called repetitive stress injuries, or RSIs. So the first one is the carpal tunnel syndrome. I get carpal tunnel syndrome myself. It's where you get a swelling inside the tunnel formed between the bone and ligament in your wrist. And this can add to tingling and numbness. I'll sometimes get some numbness in my pinky finger, and that's because those nerves are being compressed by the swelling, and it's preventing me from getting that feeling, or sometimes it'll cause pain. There's cervical radiculopathy, which is a disc compression in the neck. This is usually caused by if we're looking up or looking down at a computer screen because it's not at the right viewing angle, or because we're looking down at our phone, or because we're holding a phone on our shoulder. Epicondylitis, which is an elbow soreness, sometimes called tennis elbow. This can be caused by either having your keyboard too high or your keyboard too low, so that you're putting too much strain on that part of your elbow. Reflex sympathetic dystrophy, which is marked by dry, swollen hands and can cause a loss of muscle control. This you can get from being with having your hands on the mouse or on the keyboard for long periods of time without the appropriate support. And then tendinitis, which is a tearing or inflammation of tendons. So again, working on the computer, working on the keyboard and the mouse is going to put a lot of strain on these tendons within your wrist, within your hands, and overuse of them, just like overuse of any muscle, can cause them to tear and become damaged. With regards to prevention, I think this diagram here does a good job of showing some of the things that we should do to make sure that we're preventing any sort of injuries while we're working at the computer. First of all, hydration, always important. Just like with anything, we need to stay hydrated. Keep a bottle of water next to you when you're at the computer, away from the any of the outlets or power strips or anything else, but just make sure that you're staying hydrated while you're at the computer, not drinking soda, not drinking juice, drinking water. We should be doing what we can to prevent eye strain. So we can see in the example here, he's sitting at a proper viewing distance with a proper viewing angle from his monitor to make sure that he's not straining his eyes to be able to see what's on the screen. Hopefully also taking a break from looking at the monitor for periods of time so that he's not straining his eyes from just being bombarded with all that light. You can also see with regards to posture, having a backrest and the right elbow angles, making sure that the keyboard's at the right height. You've got clearance above your knees. You've got a seat that's at the right height. All of this is going to make sure that when you're sitting, or if you're standing at a standing desk, that you've got all of the appropriate posture so that you're not injuring your back, your neck, your shoulders, your hands, or anything else. And most importantly, taking breaks, making sure that you're getting up every 30 minutes or so, giving yourself a chance to get away from the computer, giving yourself a chance to rest from those repetitive movements so that we don't get carpal tunnel, getting up and exercising to make sure that we keep our blood flowing, our circulation, our heart. All of those things need to be taken into consideration when we're sitting at a desk for a long period of time. If you do get an RSI, ice packs will help to reduce some of the inflammation. Support, if you have a wrist injury, getting a wrist brace or something else to give support. Not too tightly. We don't want to constrict it. We don't want to stop blood circulation, but just something to give it that extra bit of support. Rest those injured areas. Take an anti-inflammatory like an NSAID. If just follow the directions on the anti-inflammatory to make sure that you're taking the right dosage. After applying ice, a heating pad might help to relieve some of the inflammation as well. And eventually, if it does not go away, seeking proper medical attention at a doctor. So that's it for safety. That should give you all the information that you really need to know in order to complete the materials online, and the materials in the workbook. If more detail is in the programming merit badge series book. I'm going to give out a PDF copy of this as well that you can refer to. Also, just worth mentioning, you should probably have some sort of a book if you're going to be learning how to program, some sort of a book that you can use to teach yourself programming. I'm really going to be going into some of the conceptual elements here, but I'm not really going to be getting into the details of how to program. So having a book like this, Python for Kids, this one I highly recommend. It's a really good book, but there's a lot of books that are designed for programming for kids. Some of them are specifically with gamers in mind. So if you want to program your own game and you want to pick up a book on Unity or Minecraft or one of these other programming languages specifically for these games, those are just as good as any other. They're going to teach you a lot of the same core concepts. So let's talk a little bit about the evolution of programming languages. So back in when computers were first being introduced, the main way of communicating with the computer was through binary code. And this still stands true today. Binary code is ones and zeros. So a lot of times you've probably heard that the only thing a computer can understand is ones and zeros. And that's true. There's all of the circuits that are in computers are all based on every one of them being in one state or the other. Either it's on or it's off. It's 1 or it's 0. So that binary code is the way that computers understand how to actually perform arithmetic, how computers understand how to display things on the monitor, how to interpret different inputs through mouse or keyboard. Everything in a computer translates back to those ones and zeros. So back when computers were first originated, that was really the only way to communicate with them. You had to understand how the computers handled binary arithmetic, and you would code things in binary. And for that reason, computers of that time weren't able to do nearly as many things as they're able to do today. But over time, computers were becoming more prevalent, and higher level programming languages like assembler came along. Assembler was a way for us to actually be able to write variables, give names to different things, put logic into our programs so that the higher level language, the assembler language, would allow us to type in a human readable format, something that could actually make sense to the person writing the program or make sense to somebody else who has to go in there and make edits to that program later. and the computer would take care of translating that into the machine code, the binary code. This was a big advancement, but it still left a lot of limitations because those assembler programs were very hard to write, very hard to read. So along came, and one of the biggest deterrents of them were they were machine dependent. So if you had a particular mainframe computer that you were programming for, the assembler language for that computer may not be the same as one that you've previously worked on or one that you're going to work on in the future. So eventually along came the next generation of programming languages, which were the portable programming languages. These were things like Fortran, COBOL, and Pascal, which allowed the programmers to write code that was much more human readable. It was designed for specific purposes, Fortran being for mathematics, COBOL being for business, and they were machine agnostic, so you can write it on one machine and it would run on any machine after that. And this kind of opened up the floodgates for a lot of the programming languages that we see today. So now we have programming languages like C, C++, Java, JavaScript, all of these other programming languages that are available to us now that all built off of the core concepts. So we'll take a look at some of the evolution of those concepts in the next slide here. So one of the biggest advancements in programming, so we talked about assembly language and we talked about some of the programming languages. They had the ability to run sequentially. So they started at one spot in the application and they finished at another, and they just ran every step in between. What programming languages opened up for us over time was when an individual named John von Neumann came up with the idea for subroutines. Subroutines were basically small tasks that you can run within the code. So if you had something that you were running repetitively in your code and you knew you were going to run it over and over again, you can put that into a subroutine which can then be called every time that needed to be called. So for instance, if you were working on a piece of technology that needed to check the temperature of the internal temperature of the particular machine that you're working on, you can write a subroutine to check the temperature, and then every time that that subroutine was run, it would return back the temperature so that your program could make decisions based off of those values that were returned. After that, we developed the concept of object-oriented programming. Object-oriented programming means that we create objects within our program that encapsulate all of the details about one particular component of our application. So this is kind of taking those subroutine concept to the next level. Now instead of just having individual tasks that we can run over and over again, we have entire components within our application that can be used over and over again. So when you think about a file menu within an application, or those type of reusable pieces that we could see used in many different applications. So when Windows first became popular back in the 90s, and object-oriented programming was what allowed us to have that kind of universal look and universal tools that we see time and time again in all of our Windows programs. And it allows us to have common variables and methods that get used over and over again in them as well. And the last big advent in programming was when we started programming for the web. So again, in the 90s, when the internet became very popular and started to become more widespread, we needed a way of taking static markup documents, which were what made up the web at that time, basically just information, pictures, and text on the screen, and making them interactive. So programming languages were developed specifically for the web, most notably PHP and JavaScript, which allowed us to take static web applications and make them into dynamic web applications, which is why now we have things like Gmail and Google Docs and all of these other applications that we can work with right in our browser, because we have programming languages like JavaScript which allow us to do that. So hopefully that gives you all the information that you need to really handle that the history piece. And lastly, I just want to get you started on some of the project for section for requirement 5, specifically requirement 5A. I've created here what's called a JS bin. This is a small JavaScript file that is available in the browser. So I'm going to open up my browser here, and we're actually going to we've got this we've got this small program up here which takes a variable called today's date, and it creates a date in JavaScript, and then it does some stuff here. And I'm not going to go into detail about what this does, because really the idea here is we want to take all of this complex logic here that we have, which is going to take the date that we created and put it into this format so that it can display properly to the user. And in this statement right here, it's actually taking that date and putting it into that box. If I wanted to put something else in here, I could say hi. But we're going to keep it as today's date. So what we want to do is we want to take all this information and we want to put it into a subroutine. So I'm going to take this out of my application right here. And now you can see it's actually put a bunch of other stuff in there, because we no longer have all of that code that I wrote to actually format the date properly. And we are going to create a function. So in JavaScript, we create a function by saying const getDate equals function. And then we have to pass a parameter to it. So we're going to pass today's date. And then we put these curly braces, which means everything within these curly braces is the code that we're going to run in our function. And I'm just going to paste in all of the code that we had earlier. And this is going to do a few things. It's going to take today's date, and it's going to do all of the same functionality, except it's going to put it into this subroutine, which can be called again and again. And then the only other thing we have to do is we actually have to call this function. So we're going to say today's date equals, and then we're going to call our getDate function, and we're going to pass today's date in. Okay. Now, one thing that we forgot to do here is at the very end of our function, we passed a parameter to it. Now we have to return a value back to that when we called the function. So we're going to say return today's date. And there we have it. So this, although there's actually more code here than was originally, it makes our code much cleaner, much easier to read, because we can see right here, today's date equals getDate today's date. It tells us exactly what's happening here. And we can even add some comments in here to say getDate input a date, output a string representation of date. And we can put as much detail into that, into those comments as we want. So ultimately, this is going to give us the option of writing out some functions that can do different routines. And you'll see, like, if this is something that we needed to call many, many times, imagine having to write that code over and over again. Instead, we could just write it once, put it into this function, and use it as many times as you want. And ultimately, what your programs will end up looking like, they'll look like just a series of functions being called, because everything can be put into subroutines. So I'd like you to try this out. I gave you the link to the JS bin. You can try putting this into a function yourself and testing it out. If you find that you're running into any problems debugging it, you can pull up the console over here, and you can usually see if there's an error that pops up. And if you have any questions, don't hesitate to reach out to me. My contact information is in the PowerPoint. So when we get together next, hope to have another video out by tomorrow. We're going to take a look at some general knowledge, just looking at what some of the programming languages that are in use today. We're going to look at some different program devices and how they use what type of software they use to run, and then we're going to take a look at doing some coding from scratch. So again, this is something that's fairly abstract. I just wanted to give you an idea of the usefulness of subroutines. But when we look at some of the next programs, we'll be looking at things from the ground up to hopefully make sure that you understand all of the lines of code that we're writing. All right, thank you very much, and we'll see you on the next lesson.